Welcome to part 3. We're going to do a walking problem now that has an incline. So to do a walking problem with an incline, we're going to first figure out the horizontal portion, then we'll do the vertical portion or the incline portion, and then as always we're going to add to rest. So what is the first thing that we do here? Well, we want to convert miles per hour to meters per minute. Do you remember how to do that? Multiply by 26.8. So we have our 2.5 miles per hour times 26.8 meters per minute per mile per hour. I'm going to get 67 meters per minute. So this is how I convert 2.5 to meters per minute. To do the horizontal portion, it's 67 meters per minute times 0.1 mils per kg per minute per meter per minute. That's going to give me 6.7 mils per kg per minute. That's the horizontal. Now what do we have to do? We have to do the incline portion. To do that, I use the same speed, 67 meters per minute times 1.8 mils per kg per minute per meter per minute. That's a constant that I've been given. And now I take my 1.5% and turn it into a decimal. To do that, I move the decimal 2 places. So I get 0.015. This is equal to 1.5 because it's 1.5%. That means per 100. So I take this decimal place, I simply move it. So if it was 2%, it'd be 0.02. So meters per minute times 1.8 times the percent incline represented as a decimal, I get 0.015. So this gives me 1.8 mils per kg per minute, which is the vertical component. To get the whole cost, I do 6.7, which is the horizontal component, plus 1.8, which is the vertical component, plus 3.5 mils per kg per minute. That's the resting component. And all total, it's 12.0 mils per kg per minute. So if this same person that was at 12 mils per kg per minute, if we want to do caloric expenditure, then we have to know her weight and how long she's going to be moving. So to get METs, we take 12.0 mils per kg per minute and divide it by 3.5, which gives me 3.4 METs. I'm going to take the 3.4 METs, plug it into my equation, which is METs times 3.5 times body mass, divide all of that by 200, and I get 3.5 kcals per minute. If she walked at this pace for 30 minutes, it's simply 3.5 kcals per minute times 30 minutes equals 105 calories. So not that challenging. It's pretty straightforward once you understand what the numbers represent. Now let's look at running. We do it the same way. We have a horizontal component and a vertical component and a resting component, but we just change our coefficients. So for running, instead of 0.1, we're going to do 0.2. So it's funny, for the horizontal component, when we go from walking to jogging, we multiply by 0.2, and then for the vertical, we divide by 2, or we multiply by 2, which is 0.1 times 2 is 0.2, and then we divide by 2, which is 1.8 divided by 2 equals 0.9, and the rest remains the same. So let's do an example. We have a male. We want to calculate their VO2. They're running at 7 miles per hour on a 3.0% incline. So how do I convert miles per hour to meters per minute? I multiply by 6.8. So 7.0 miles per hour times 26.8 meters per minute per mile per hour gives me 187.6 meters per minute. That's my horizontal component. I take the meters per minute that I just calculated, and I multiply it by my given, which is 0.2. Remember, 0.2 for jogging or running, 0.1 for walking. So 0.2 mils per kg per minute per meter per minute, and I get 37.5 mils per kg per minute. For the vertical component, I'm going to multiply my speed, 187.6 meters per minute, times my coefficient, that's a given, 0.9. Remember, for walking it's 1.8, but for running it's 0.9. And I have to multiply this by the percent incline represented as a decimal. This is a point where some students make a mistake. They'll multiply by 3.0. You don't do that. You take this decimal and move it 2 places to the left, 1, 2, and you get 0.03. So the vertical component is 5.1 mils per kg per minute. If I look at all total, I got the horizontal plus vertical plus rest. So horizontal is 37.5 plus vertical is 5.1 plus rest is 3.5. That gives me 46.1 mils per kg per minute. So I'm going to pause there. So if I know the mils per kg per minute in relative terms, that's the 3.5 mils per kg per minute. If I know it in absolute, so if I'm given VO2 in liters per minute, one of the advantages is I can simply multiply it by 5 kcals per liter per minute. Let me show you what that looks like. So if I know my absolute VO2 in liters per minute, so if it's 2.4 liters of O2 per minute, I can multiply by 5 kcals per liter per minute to get my number of kcals per minute. So 2.4 in liters of O2 per minute times 5 kcals per liter of O2 equals 12 kcals per minute. The liters of O2, those cancel out, those units cancel. So the caloric equivalent of 1 liter of O2 ranges from 4.7 kcals per liter for fat and 5.0 kcals per liter for carbohydrate. So we just round that to 5.0. So if you're given absolute VO2 on a test, simply multiply it by 5 kcals to get your kcals per minute. So to convert relative VO2 to absolute VO2. So if we have VO2 expressed in mils per kg per minute, how do I get to liters per minute? All right, so I have mils per kg per minute, which is a common value. How do I get to absolute VO2? If I have absolute VO2, I simply multiply by 5 kcals per liter of O2 to get kcals per minute. So my first step, I multiply VO2 by body mass in kilograms. And then I divide by 1,000 milliliters per liter. So I'm just dividing it really by 1. For a 198-pound man with a VO2 of 46.2, it looks like this. 46.2 mils per kg per minute times 90 kilograms. 90 kilograms is 198 pounds divided by 2.2 to get 2 kilograms. So I take 46.2 mils per kg per minute and multiply it by the body mass, which is 90 kilograms. When I multiply by 90 kilograms, this kilogram is going to cancel out. So I get 4,158 mils per minute. Now all I have to do is divide by 1,000 and I get 4.16. I've rounded up 4.16 liters per minute. So if you're given relative VO2, which I'll give you relative VO2 on a test and say, hey, how do you go from relative VO2 to absolute VO2? This is how you do it. You multiply by body mass in kilograms times VO2 in mils per kg per minute. And then you divide by 1,000, and that's going to give you absolute, which is liters per minute.